Dear students, today we are continuing with the sums of exercise 1.1 of the lesson complex numbers. Question number 7. Evaluate the following. Here the higher powers of I are given. Second one, I raised to 888. We know that I square is minus 1, I cube is minus I, and I raised to 4 is equal to 1. And we use the method that we have already learned to find the higher powers of I. That is, we divide the exponent or the power of I by 4 and write the exponent as the divisor into quotient plus remainder, and the remainder part we will write separately as the power of I. Here 888 is a multiple of 4, so we write it as I raised to 4 raised to 222, and we know I raised to 4 is 1, so 1 raised to 222 is equal to 1. Next, fifth one, I raised to 403, and we write I raised to 403 as I raised to 4 raised to 100 into I raised to 3. Here 3 is the remainder when we divide 403 by 4. So we write this remainder part separately as a power of I. And I raised to 4 again 1 raised to 100 is 1 into I raised to 3 is minus I, that is minus 1 into I, or you can directly write minus I, that is 1 into I raised to minus I, that is minus I. Next, eighth one, I raised to 30 plus I raised to 40 plus I raised to 50 plus I raised to 60. And here I raised to 30 is I raised to 4 into 7 into I raised to 2. 4 sevens are 28 plus 2. So remainder part we write separately. So I raised to 4 raised to 7 into I square, and I raised to 40 can be written as I raised to 4 raised to 10, and I raised to 50 can be written as I raised to 4 raised to 12, that is 4 into 12 48, and remainder is 2. So I square is written plus I raised to 60 is I raised to 4 raised to 15. 4 15s are 60. Now all the bracket part is 1. I raised to 4 is 1. 1 raised to 7 1. And I square is minus 1. And here only 1. Here 1 into I square is minus 1. And I raised to 4 raised to 15 is 1 raised to 15. So minus 1, first term is minus 1 and second term is 1, and third term is I raised to 1 raised to 12 into minus 1 plus 1 raised to 15 is equal to negative 1 plus 1 0, negative 1 plus 1 0 is equal to 0. Question number 9 1. Find the value of I raised to 49 plus I raised to 68 plus I raised to 89 plus I raised to 110. We know I raised to 49 can be written as I raised to 4 into 12 into I, that is 4 12s are 48 plus 1. 1 is the remainder written I raised to 1. And I raised to 68 is I raised to 4 raised to 17. I raised to 89 I raised to 4 raised to 22 into I. And I raised to 110, I raised to 4 into 27, 108, and 2 is the remainder. So I raised to 2. Now bracket I raised to 4, all the I raised to 4 terms equal to 1. 1 raised to 12 into I, 1 raised to 17 plus 1 raised to 22 into I plus 1 raised to 27 into minus 1, because I square is minus 1. So first term I, second term 1, third term I, fourth term minus 1. So 1 and minus 1 got cancelled. 1 plus I, 2I. Now question number 15. There is a question number 11, which is important, which is solved later after this sum. Question number 15. Prove that 1 plus I raised to 4 into 1 plus 1 upon I raised to 4 is equal to 16. So we will consider the left hand side first. That is 1 plus I whole raised to 4 into 1 plus 1 upon I whole raised to 4 is equal to. Both are having the same exponent, so we can write both the brackets under the same exponent, that is 1 plus I into 1 minus I whole raised to 4. and 1 plus I into 1 minus I, and this one more thing, 1 plus 1 upon I can be written as minus I. These all things we have already learnt. 1 upon I is minus I. And 1 plus I into 1 minus I is of the form a plus b into a minus b. That is a square minus b square form. That is 1 square minus I square. 1 square is 1 minus I square is minus 1 whole raised to 4. And 1 minus of minus 1 is 1 plus 1 2. 2 raised to 4 is nothing but 16. That is RHS. So we got LHS equal to RHS. Question number 11. Find the value of 1 plus I square plus I raised to 4 plus I raised to 6 plus I raised to 8 etc. plus I raised to 20. Now we have the terms between 1 and I raised to 20 in the same manner or in a series. 1 plus I square plus I raised to 4 plus I raised to 6 plus I raised to 8 etc. 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 plus I raised to 20. That is 10, 12, 14, 16, 18. Again we have taken the powers of I in between. Now we arrange them as a pair. First one is written plus, now the consecutive terms, two consecutive terms we have written or added together, and I square plus, and the second term is also written as a power of 2 by dividing the exponent by 2. That is I raised to 4 can be written as I square whole square. Next one I raised to 6 can be written as I raised to 2 whole raised to 3. I raised to 2 whole raised to 4. I raised to 2 whole raised to 5. This way we will write all the terms. Last one I raised to 2 whole raised to 10. Now we know I square is minus 1. And here minus 1 raised to 2. That is positive power of negative 1 is positive 1. And negative 1 raised to 3 is minus 1, negative 1 raised to 4 is 1, negative 1 raised to 5 is negative 1, negative 1 raised to 6 is positive 1. This way we will write all the terms. Negative 1 raised to 7 is negative 1 plus negative 1 raised to 8 is positive 1, and negative 1 raised to 9 is negative 1, and negative 1 raised to 10 is positive 1. Now we will see each bracket contain negative 1, positive 1, negative 1 plus 1, 0. So all these brackets are 0 except 1. 1 is equal to 1. So we got the answer as 1. Number 18. If x plus iy is equal to a plus ib the whole cube, show that x upon a plus y upon b is equal to 4 into a square minus b square. So we will write the given equation first. X plus iy is equal to a plus ib the whole cube. Now we will expand this RHS part as a plus b the whole cube form. That is a cube plus 3a square b. But here in place of b we have ib. So 3a square ib plus 3ab square, that is 3 into a into ib the whole square, plus b cube means ib the whole cube. So a cube plus 3a square into ib plus 3ai square b square. We can write the exponent separately for I and b, plus I cube into b cube. Now a cube plus 3i into a square b minus I square is minus 1. So we can write this term as 3 minus 3ab square minus I cube is minus I. So last term is minus I into b cube. That is a cube minus 3ab square. What is this? We have collected the terms without I together and the term containing I together. That is first term a cube minus 3ab square plus I into 3a square b minus b cube. So x plus iy is equal to a cube minus 3ab square plus I into 3a square b minus b cube. Now compare the real and imaginary parts on both sides. That is, this is a complex number, real part and imaginary part. So real part is x. In the left hand side, right hand side is a cube minus 3ab square. So x is equal to a cube minus 3ab square. Now a is common in these terms. So we will take a common and divide by x, that is x is divided by a. That is x upon a is equal to remaining terms, that is a square minus 3a is gone out. So a 3b square here. Similarly, we will equate the imaginary part, that is y. Y is equal to 3a square b minus b cube. While writing the imaginary part, we don't consider I, only the real number we are taking as imaginary part. Now, y is equal to 3a square b minus b cube. So, y upon b, that is b is common in these two terms. So, we divide by b is equal to 3a square minus b square. Now, we will add both this x upon a and y upon b. So, a square minus 3b square plus 3a square minus b square. So, we add the like terms. So, a square and 3a square is 4a square minus 3b square minus b square minus 4b square. Therefore, the required condition we proved. Number 20. If x plus iy is equal to root of a plus ib upon c plus id, prove that x square plus y square the whole square is equal to a square plus b square upon c square plus d square. The given condition is x plus iy is equal to root of a plus ib upon c plus id. Now we square on both sides to remove the square root of this a plus ib upon c plus id. So, left hand side will become x square plus 2x into iy minus y square. Minus y square is because iy the whole square and I square is minus 1. And right hand side the square root will get removed. So, a plus ib upon c plus id. Now, we collect in the left hand side we collect the terms without I. X square minus y square plus I into 2xy is equal to a plus ib into c minus id divided by c plus id into c minus id. That is, we multiplied both numerator and denominator by the conjugate c minus id of the denominator, that is c plus id. Now we combine this, open these brackets and combining the terms, we will get AC plus I into BC minus I into AD minus I square into BD divided by C square plus D square. And AC plus BD, that is the term without I, that is minus I square is minus I square is minus of I square is minus 1. So it will become plus 1. I square is minus 1, minus of minus 1 is plus 1. So, plus BD it will come. Now, we collect AC and BD together because they are without I. And I into BC minus AD. Now, we separate the denominator for both the terms like real part and imaginary part. So, equate the real and imaginary parts on both sides. We will get x square minus y square is equal to AC plus BD upon C square plus D square, and imaginary part 2xy is equal to BC minus AD upon C square plus D square. So, we wrote it separately. Now, we use the identity. X square plus y square the whole square is equal to x square minus y square the whole square plus 4x square y square. This is of the form a plus b the whole square is equal to a minus b the whole square plus 4xy. Sorry, 4ab. So, x square minus y square the whole square plus 4x square y square can be written as 2xy the whole square, and we substitute the values. X square minus y square, the x square minus y square is AC plus BD upon C square plus D square the whole square, and 2xy is BC minus AD upon C square plus D square and whole square. That is, we will expand these terms separately, and the denominator is same for both the terms. So, we took it together, combined form. So, AC plus BD the whole square plus BC minus AD the whole square upon C square plus D square the whole square. Now, expand this bracket using a plus b the whole square and a minus b the whole square form. We will get this a square c square plus 2abcd plus b square d square plus b square c square minus 2abcd plus a square d square. Now, 2abcd will get cancelled, and a square plus b square the whole square, a square plus b square into c square. C square is common in these two terms, a square c square plus b square c square, and d square is also common in the terms b square d square and a square d square. So a square plus b square into d square divided by c square plus d square the whole square. And a square plus b square is common in these two terms, taken together out, then a square plus b square into c square plus d square divided by c square plus d square the whole square. Now 1 c square plus d square the whole d square plus c square plus d square will get cancelled from numerator and denominator. You will get remaining terms a square plus b square divided by c square plus d square, that is x square plus y square the whole square is equal to a square plus b square upon c square plus d square. Question number 24, first one, find the values of x and y which satisfy the following equations. X plus 2y plus 2x minus 3y into I plus 4i is equal to 5. Now, we will take this plus 4i to right hand side, then it will be x plus 2y plus 2x minus 3y into I is equal to 5 minus 4i. This is of the form, both sides are of the form of a complex number. Now, equating the real and imaginary parts, we get x plus 2y is equal to 5 and 2x minus 3y is equal to minus 4. Now, equation number 1 into 2, we will get 2x plus 4y is equal to equal to 10, and we subtract the equation 2 from this, then we will get 2x minus 2x cancelled, 4y minus 3y, 4y minus of minus 3y, that is 7y, and 10 minus minus 4 is 10 plus 4, 14. So y is equal to 2 from these. Now putting y is equal to 2 in equation number 1, we will get x plus 2 into 2, 4 is equal to 5, x plus 4 equal to 5 means x is equal to 1. So the values are x is equal to 1 and y is equal to 2. Question number 24, fifth one. If x plus 2y plus 15 I raised to 6y is equal to 7x plus I cube into y plus 4. Find x plus y. So, we will write x plus 2i plus 15 I raised to 6y is equal to 7x plus I cube into y plus 4. And I cube is minus I. So, we will take the real part, that is here in the left hand side, 15 into I raised to 6 is minus 1. I raised to 3 is minus I, and I raised to 3 again, then I raised to 3 into I raised to 3, that is I raised to 6. So, I raised to 3 minus I into minus I square minus 1. So, x minus 15y plus 2y is equal to 7x minus I into y plus 4. Now, we will equate the real and imaginary parts, that is x minus 15y is equal to 7x. So, 7x and minus x, that is 6x plus 15y is equal to 0, that is equation number 1, and the imaginary parts are 2 is equal to y plus 4, that is minus of y plus 4. So 2 plus y, 2 is equal to minus y minus 4. So y is equal to minus 4 minus 2, that is minus 6. So we got y is equal to minus 6. Now we substitute this value in equation number 1. Y is equal to minus 6 in equation number 1, that is 6x plus 15 into minus 6 is equal to 0, and 6x is equal to 15 into minus 6 is minus 90. Take to the right hand side, then it will become plus 90. 6x equal to 90, then x is equal to 90 upon 6, that is 15. So we add x is equal to 15 and y is equal to minus 6. So x plus y is equal to 15 minus 6 is equal to 9. Now the next part is continued in the next video. Thank you.